Thank you for nice introduction and good morning, everyone. Yeah, I will talk about two projects today, which is focusing more about the geomechanics, how it is important in the CO2 storage. So it's when we talk about the monitoring, we are looking for some change in different different parameter and different phenomenon. But what we should remember is that we always to learn better how subsurface is behaving once you start your work and you get the data. So you need to go back and again and see, checking your subsurface, how it is before the injection and also afterwards and during your operation. So the first project I want to present is about, its short name is SENSE. It's about assuring integrity of the CO2 storage site through the ground surface monitoring. So this is about looking at how surface deformation, mechanical deformation is related to subsurface behavior, including pressure in the reservoir. So we have many partners in Europe and also from States, but also we had three non-act country members from Japan and Korea and Australia as well. And they did a lot of good work for the project, and we were really happy to be able to cooperate. And the project started from 2019 to this year, it's the last year. Yeah, so in SENSE, sorry, I have changed my glasses. The ground movement detection for continuous and cost-efficient way so that we can make sure that the subsurface is behaving as we expected. So we're looking for the demonstration of a tool and some methodology that we can apply both onshore and offshore. And we wanted to optimize how to sensor has to be deployed, for example, especially for offshore, because putting something on the seabed is quite expensive. And then once you have the data, you have to analyze and you have to be able to explain the data through simulation. And at the end, we hope that we can make sure the safe CO2 storage and also kind of using this surface deformation as an early warning system. Yeah, so as you can see here that the surface deformation is something you can see from INSAR, from the satellite. But also you can put something, pressure sensor on the seabed or some other tool on the seabed, you can make a deformation. But all the origin of this deformation should come from what you did into your reservoir. So then you can connect between top surface and the reservoir, not only these two ends, but also what's happening in between. That's why we need to have a better understanding of the mechanical behavior through the whole subsurface. So we defined several case study for the SENSE project, and something was going very well, but some of them was not going well because of a lack of data and some practicality. That was also quite good learning that what you plan is not always happening according to your wish. So in Japan and Norway, we also utilized kind of a new technology of fiber optic so that we can measure deformation at the surface using fiber optic to cover large area, which can be also useful for offshore because you don't have a satellite possibility in the offshore. So as I said, pressure buildup due to injection will make a change in the subsurface, and that will be shown in the top of the surface. And then we can model those data and then invert, and then we can explain back what's happening in the subsurface. And that is sort of a whole story of the SENSE project. And then we integrated the different partners' contribution from UK and Germany and Norway and Spain and also those three companies from Asia. And then we tried to come up with how we can really maximize the value of the ground deformation to make sure that we do things correctly with the subsurface. And just one of the example from our learning was how we can use the fiber optic to measure deformation in the subsurface. So, I mean, yeah, we're looking at, what we're looking at is the vertical deformation, but the fiber optic is you measuring strain along the axial direction. So you need to understand how we can convert one parameter to the vertical deformation. That was a bit challenging. So we did a small test in our backyard. We made some sandbox and put some mechanically, you can lift it up to your surface, and then you put the different type of layout of your fiber optic cable, and we measure the strain. And then what we learn is that it is a very sensitive tool, maybe too sensitive, but applying to the CO2 storage deformation, there is a bit challenge because you can measure very sensitive small deformation, but laterally you need a quite high change, not like a, I mean, like in Sala case, we had like a 2-3 centimeter over the few kilometers, but in this case, we have like a 2 meter length that you can detect. Yeah, okay, that was the one of the big learning from SENSE project. The second project is called SHARP. The full title is Stress History and Reservoir Pressure for Improved Quantification of CO2 Storage Containment Risk. Yeah, many partners are listed here, and some of them are here as well too. So the main idea, the SHARP, is that it's nothing new. You know that when you inject something, you trigger something in the subsurface, you may have some incident, may not, you don't have, but there are some uncertainties that we're already aware of, but we don't know how to control. So we know what's important, but we don't know how we can quantify those uncertainties. And then after that, we want to make sure that we have a better understanding of the subsurface, including in situ stress and also stress history, that we can have a better position that controlling, managing the subsurface behavior, and also monitoring. So different countries, different partners define the relevant field cases for each country, and each cases have a different aspects. So and then we can talk together, then we can learn a lot through this SHARP project. That was the main idea of this consortium. So this is one of the recent results that we look at all the seismicity data in North Sea, and then we collected something relevant for the whole of the platform area and North Sea, and then we come up with how stress is, in situ stress is available along the depth in this region. Yeah, and then we also look at some effects of the glaciation on the stress state, and then this is an example from Dogobank area. You can see that it's very complicated geology, and then there's an influence from glaciation, and then we want to understand better how this is affecting the in situ stress, and also how it's affecting into our CO2 operation. And as I said earlier, that quantification is quite important, but there is no such any good guideline so that you can use it. Of course, the making guideline is very challenging itself, but at least we should have something. So we want to come up with how we can have a quantification of your mechanical properties that are using your operation. And the second thing was looking at the containment risk. And then we want to also have some quantification tool that we can model how, if something happens, how the fault behaving and how your flow, what you should expect through the fault. Or we didn't include specifically the well leakage, but we focusing on the fault leakage here in this SHARP project. And SHARP project started last year, and then and maybe the year after. And both projects, SENSE and the SHARP, will have a presentation and posters in GHGT 16 as well. Thank you so much.